So for this one, what I really want to do is I really just want to I want to talk about word problems. I want to talk about what we see. So this is page, what page is this? This is page 34 for the homework tonight. A whole lot of this is just going to be talking about word problems. So I want to make sure that we're looking for the right information when we're looking at this. So when you look at number 4 here, it says, Jade is stranded downtown with only $10 to get home. Taxis cost 75 cents per mile. I wish. But there is an additional $2.35 higher charge. Write a formula and use it to calculate how many miles she can travel with her money. And this is even including tip. You should always tip, but we'll talk about that later. All right. So what we have to do every time we look at a word problem, I feel like a lot of times our brain just kind of shuts down. We're a little bit overwhelmed. But I mean, I don't like the idea of calling them just word problems. These are real world problems. Real world problems. Because if you need to get home and you only got $10 in your pocket, you got to figure it out. So the first thing that we're going to do whenever you see a word problem is I want you guys to find the important numbers. Right? We have 10. We know she has $10. We know it's 75. Whoa, why is it doing that? We know that it's 75 per mile. And there's a higher charge here. Okay? Now, one of the things I want you guys to get in the habit of looking for is this number right here. Or this word. Per. Per. Anytime we see the word per, that means we're going to be multiplying. Okay? Multiplying. Okay? And so what are we trying to figure out? We're trying to figure out how many miles here. So when I think about what my equation is going to be, that's going to be the important information. I know that I have additional. Well, you can even see additional has the word add in it, right? It has the word add in it. So what do you think we're going to do? Well, I see that I have 75 cents per mile. So I go 0.75 per mile. Just like that. And an additional $2.35. So I'm going to add $2.35. $2.35. And what's that going to equal? What's that going to equal? Yeah.
$10.
Yeah, $10. I got to see how far I can do this with $10, right? You guys see that? And so we have to look at what's actually going on with these problems. I've now created this. This is just a two-step equation from here. You can solve it from there. Yeah.
Another thing would be 10 minus 2.35, then divided by 0.75.
Equals that. Yeah, that's what we're going to end up doing with this. Absolutely. That's how you would start to solve this. Yeah. Okay. So now let's look at Jasmine's dad and see what she's doing. Jasmine's dad is planning a surprise birthday party for her. Do we care about this for the sake of our problem? No. This is just we don't like Jasmine, we don't like her dad, and we, gosh darn it. Oh, and he will hire a bouncy castle. Those of you in my lit class, you guys know we hate bouncy castles. Bad things happen when you have a bouncy castle. It'll just blow in the wind, man. It's dangerous. And we'll provide party food for all the guests. Now we're getting to the good information. The bouncy castle costs $150 for the afternoon, and the food will cost $3 per person. And again, we have per. That tells me multiplication is at work here. Andrew, Jasmine's dad, we don't care what his name is, has a budget for $300. That's a lot of money for a birthday party. Write an equation used to determine the maximum number of guests you can invite. So what I want you guys to do right now is I want you to try to do this one on your own. Using the tips that I gave you. Look at the numbers, understand what per means, and try to come up with something. Pause it. Really? You're not going to try it? Come on, man. Here we go. Here we go. Honest effort, guys. Honest effort. Let's see if this guy looks better than my finger. How do you guys have it? All right. What do we have? What do we have here? Yeah.
I don't know if this is right, but I said 3P plus 150 equals 300.
3p plus 3 plus 150.
Yeah.
150 equals 300. Is that right?
Yeah.
Why is it right? What's going on here? What are the elements that we're talking about?
You're multiplying by people. You're multiplying this 3 by people.
So that's this here. Where's the 150 coming in from? Bouncy Castle. And that's our budget. So you can see this. Food per person plus Bouncy Castle equals my budget. Okay, when you guys get married and have to do your wedding planning, this is going to come into play. How much can we afford? Yeah.
Can I see the answer?
What's that? Yeah, and so what does that end up being?
P equals 50, I guess?
P equals 50. So you can have 50 people. Okay? I had to do something very similar to this for my own wedding. We have to rent how many chairs? They're this much. Tables are this amount. Yada, yada. What's that? Hey, our budget was spot on, you know. All right, so all I really wanted you guys to get out of this is I want you guys to not get overwhelmed with these word problems. I feel like sometimes our brains just shut off when we see these. We don't have time for that. What you need to do is just do what I did. Look for the important information. I highlighted the numbers. Pay attention to the word per. That usually means multiplication. And then just try to make sense of the situation. All right? And that's it. There's no new skills. It's just presented as word problems. All the skills are exactly the same. When you look down to the go section, okay, we have 7 and 8 and 9 here. I want to draw your attention to this. This time, it's asking us to solve systems. And what are systems again? What are systems? We talked about it yesterday. Yeah. Multiple equations. Thank you. And so what that means is we are going to be looking at multiple equations for these problems. So for this one, Mary's car has broken down and it'll cost her $1,200 to get it fixed. Or for $4,500, she can buy a new car. That or tells us that this is going to be the second equation, right? That's our second equation. Okay? So I'm going to highlight one equation. I'm going to red the other equation. The highlight equation is to fix your car. The red one is her new, if she buys a new car. She's got to make a decision in life. Her present car uses about $2,000 worth of gas. So is that highlighted or is that red? Highlighted, right? It's the old car. While gas for the new car would cost about $1,500. Is that highlighted or red? Red. It's the new car. Okay? After how many years would the total cost of fixing the car equal the total cost of replacing it? Years, years, years. So years is going to be our variable. Years, years. So years is our variable here, okay? So with that in mind, we're going to create two equations. We're going to create one for the old car and one for the new car. Once we have them, see where they cross. You can graph them. and see where they actually cross. Okay? So look for that in both of these. Make sure you find your red and your yellow equations because it's going to be a system.